All right, so I'm Thorsten Lorenz. I work for NodeSource. And I've been working with Node.js for a few years now. Lately, I've been doing this remotely, so this would be a typical office I'm working from. And today, I'm going to be talking to you about a feature that was added quite recently to Node.js called Async Hooks. So why do I talk about Async Hooks? Well, if you have a production Node.js app and it's running, there'll be like hundreds of concurrent operations taking place simultaneously, right? And any serious Node.js developer at some point wants to get some insight, like wants to maybe inspect what's going on in the process, may want to debug it, right? And initially with Node, that wasn't possible at all. So there were early solutions that people attempted, and mostly they involved patching Node core module functions or maybe patching the event emitter. And there were other solutions, and they did give you some insight, but none of them were really that great, and most of them actually had quite a performance impact. So you had the choice of running your app performing really well, but you had no insight at all, or you could, get some insight, but then you had to sacrifice a lot of performance. So some decided we can do better. And the result of that are async hooks, the missing piece of Node.js. These are the voyages of the Node.js core team. Its 4-year mission to explore strange new APIs, to seek out new ways of capturing asynchronous operations, to boldly propose pull requests that no one had proposed before. I'll give you a short recap of the history of Async Hooks, and then I will show you the API that it provides to allow you to capture any asynchronous operation going on inside your process. And finally, I will show you a higher level API that then allows you to put those operations in context with what you are doing in your app. So in my opinion, async hooks are the perfect solution to the problems we just stated. They are a generic solution to capture any asynchronous activity in your process, and they give you a very flexible API, and using the API has minimal performance impact. But we didn't get there right away. So let's start in August 2013 when Thorsten Lorenz proposed the continuation local storage module. And that would have allowed to basically propagate data with async requests. So you could have kind of identified the requests at each stage, and you could have gotten information about it. But that attempt was deemed too specific, and at that point, Trevor Norris's quest for a more generic API began. And just a month later, roughly, in September 2013, the async listener pull request was merged into core. The goal of that was to have zero overhead while not in use and still provide a very flexible API. However, we'll see what happened. But with that pull request, the async wrap class was added as a central point to basically track any asynchronous operation going on. And that async wrap class is very important because that's still there today. However, in 2014, just about a year later, a little more than a year, that async listener was removed again because there were certain problems that they couldn't figure out that affected all of core. Couldn't figure it out, it had to go. However, right before that, they added hooks to the async wrap class and a native binding for JavaScript in order to facilitate experimentation to hopefully come up with a better solution. And it took a while. About another year later, we see the first activity again. Trevor committed the first async hooks commit. And in September 2016, async hooks, there was a PR that was open for async hooks, and it was then superseded by a cleaned up version. And that one also had a lot of tests with it. And in May 2017, async hooks, that PR was merged and was later released with Node.js. And as you can see, this pull request has a lot of changes. There are about 5,300 insertions. Fortunately, half of those are tests, but still like about 2,000 plus lines are changes, right? And that's why we need those tests, because these changes are not just like in one part of Node core, but they're like pretty much all over core. It was quite a monumental feat to get this working and to get it right. And there were multiple people that helped. One of them was Andreas Madsen, who basically created a tool to visualize asynchronous operations so we could kind of see if things were kind of making sense or not. And then towards the end, I joined and added a bunch of tests to make sure that this thing works as it should. As I said, it affects all of core, so it definitely has to work. And so we were able to find some issues with those tests and fix them and so on. So now we get to how that actually is important to you, right? So first of all, we need to figure out what are async hooks, what do they do? And to figure that out, we need to understand what are asynchronous resources. So when you, for instance, open a file, right, you do fs.open, under the hood in C++ land, some asynchronous resource is created that basically represents that operation, right, until you get called back. There has to be something that is representing what you're doing there, right? And any asynchronous operation basically implements the async wrap class, and that then allows it to track that asynchronous resource in C++. So how does that work? Well, we have the async wrap class here, and then we have the direct inheritors. And some of them kind of you can tell from the names like what they would relate to, like HTTP2 session, you can kind of tell. Then there are some that are more generic, like handle wrap or query wrap and so on. So let's look at some of them closer. So handle wrap itself has inheritors, right? And obviously then these inheritors also are async wrap, right? And thus they are also asynchronous resources. So for instance, we have the fs event wrap, which is created when you watch a file. We have a timer wrap, which is created when you create a timer, and so on. If we look at the rec wrap class, we have inheritors, for instance, fs-rec wrap, which basically for any file system operation, you created fs-rec wrap under the hood. A get address info rec wrap, these are kind of difficult to pronounce. These are created, for instance, when you do a DNS lookup. Here we have a longer inheritance chain, pipe wrap, multiple levels of inheritance, but still it's inheriting from async wrap, and thus it is still considered an asynchronous resource, and it can still be tracked. And if you create a network connection, for instance, a pipe wrap is created. If you spawn a child process, in order for that child process to communicate with the parent process, there's a pipe, so there's a pipe wrap created. And here are the providers that basically are used to identify the asynchronous resources. It gives you at least an idea of what type you're dealing with, right? And you can see that the names kind of map to the class names that we looked at earlier. So those are important for core itself, but it's also important for you as a user to kind of see what you're dealing with. So in summary, pretty much anything that is going on inside of your Node.js process, right, because we're mainly doing asynchronous operations, is an asynchronous resource and thus can be tracked by async hooks. So pretty cool. So how do you do that, right? How do you track? Well, there's an API that the async hooks module provides you to do that. And we are only going to look at, I would deem it the most important part of the API. We'll leave out some functions, and namely we're going to leave out the embedder API because it's a little more advanced. We will focus on the lifetime events of async hooks. So there are 4 lifetime events: init, before, after, and destroy. And init and destroy are only called once for each asynchronous resource, but before and after could be called multiple times. So let's look at the init first. There's this weird explanation what it does. But basically, anytime an asynchronous resource is created, you get an init, right? And you get with that a bunch of parameters that are passed to you. The first one being the async ID. So for each instance of an asynchronous resource, there's a new async ID. So basically, we'll never see the same async ID twice. And Trevor gave me some calculation where your node process could run multiple years until you run out of IDs. So it's fine. Then you would have the type, which kind of maps to the provider, right? It gives you an idea like, okay, this is something that has to do with the file system. This may have to do with the HTTP2 session or whatever. So that's the type. The trigger async ID gives you information about the execution context. That means basically which asynchronous resource was responsible for creating my asynchronous resource, kind of a parent-child relationship. And finally, we have the resource. That is basically a JavaScript object that is different for each provider type. And that gives you a wealth of information about the asynchronous resource that was created. And we'll look at it later. It has like a bunch of things hanging off it to make to enable you to kind of make sense of what's going on there. How do you use it? Well, you just basically create a init function that has that function signature. You require async hooks. Then you create a hook, pass your init, and then you enable a hook. And now if you create a timer, you will get data. So let's do that. That's the first example. So you see now that two things actually got created, a timeout and a timer wrap, right? And that's kind of the first indicator where we see that, like it's not one-to-one. Like what you're doing in your code is maybe not one-to-one what's actually happening under the hood. But so there's an impedance mismatch, but we'll have a remedy for that later in the talk. But here, for instance, can see that, yes, the timer wasn't called yet when it was initialized, obviously, and it had a timeout of 10. So you can kind of get a bunch of information just from that. One thing to note is if you were to enable async hooks after you fire the timer, like I'm doing here, you can see we set the timeout here, and then we enable the hooks here. In that case, you will see nothing, because you basically missed that event, right? You can do the same thing basically with the server. So here we have a server. I kind of hid away the initialization code in this module here. Same story though, you enable the hooks, right? After you subscribe to init, then your server starts listening. So let's see what happens then. Okay. So again, two things are created. It's kind of hard to see because it's so big, but TCP wrap is created and a tick object. And the tick object actually has on its arcs, the server is hanging off it, right? That's the resource that I kept talking about earlier. And here we can even see a little bit about the connection key and so on. So as you can see, very powerful. We get a lot of information passed to us. We can do a lot of things with it. So now you're probably wondering, what's up with this print thing, right? Like if you look here, instead of, why didn't I just use console log or something? Well, the problem is that even though console log is, to us at least, a synchronous operation, it still ends up creating an asynchronous resource. Actually, the very first time that you console log, it creates like 3 resources, but that only happens at least one time. But each consecutive console log then will still create one. So here's an example that I will run right now. So basically what I do is I log something to get these first 3 out of the way. Then I enable my hooks, and then I log something else. So if I do that, you will see that I created this other tick object here. And it has like the bright stream hanging off and all this stuff. So the problem is that if you were to console log in your init, you would cause another init, right? And you would end up in this endless loop. And I'm just mentioning this here because I hope a lot of you will play with this. And my first instinct usually is like, I'm just going to use console log, right? Well, you can't do that here. So what you're going to have to do is do something like I did, implement yourself a print function. The main key is to use process underscore raw debug. And I'm just using util here to inspect the object to make it look nice. But that's the main key. You can't use console log. Now we're going to look into before and after. So basically when you, let's say you set a timer, and right before the timeout is going to be called, it will actually call before for that asynchronous resource. And after your timer was called, it will call after. It's pretty simple. So here we basically have before and after defined, and then we pass it into the create hook function. And as you can see, there's also an ID that's passed to me, and obviously that ID is the same ID that was passed to me in the init, right? So that's how you can kind of identify which resource you're dealing with. And the output would kind of look like this. So we first have the timeout created, then the timer wrap, then the before kind of fire in the opposite way, right? So you have the timer wrap first, calling before, the timer calling afterwards. Then our user callback is called, and then the afters are called in the opposite order. Pretty simple. Now if you add a destroy, it's not much more complex. We just basically create us a destroy method, also with an ID, pass it in here, and now we get a destroy emitted as well, because once we're done, basically the timer can be collected, right? And as I said, this is spread all over core, right? So this is not something that you need to fully understand, but I just wanted to give an idea here in the next few slides where kind of this is implemented and how it's implemented, right? So we're going to have a closer look at the timer wrap and how the before and after basically work. So in the timers.js file here, that's where we import the timer wrap, because it's used for pretty much every new timer, at least if it has a different timeout. Again, something you don't need to concern yourself with too much, but that's how it is. So basically, in the start of the timer, we actually delegate on to libuv, right? That's basically where the timers are really implemented. And then we give it our timeout function. So that function will be called whenever the timer expires. And then in the onTimeout function, we get ourselves our timer rep, right? Which is the async rep. Then we kind of resolve a bunch of things, and we call make callback. And then that calls another make callback here. So again, we don't have to understand all this, but it collects more stuff. Here, it basically creates the async context, and that's obviously important for the async hooks. And then it calls the internal make callback. And that's where all the magic happens. So in the internal make callback, we create this internal callback scope. And right when we create that, before is emitted. And we'll see why in a second. Then our user callback is called, which is basically our on timeout. And then the scope is closed. And when the scope is closed, that's when the after will be emitted. And so why is it the before emitted when we create it? Well, because in the constructor of the internal scope, we'll emit before. And in the close method of internal scope, we emit after, right here. Pretty much that simple. So it's not working like that, obviously, for everything. It's slightly different for each part of Node. And there are also cases where, from JavaScript, certain lifetime events are omitted. But this is it gives you an idea how this works. So now we're actually going to look at a real example. Like this really awesome server has one method, one route. It's called /end, and it will shut down the server. And then every other route just says everything is fine, it's OK. So I just use this as a quick example here. Basically what I did, I created the server, let it run, and I let it collect asynchronous resources. And then I created a client that would fire 3 requests at the server, and the last one happened to be /end, and so it shut down the server. And this is the data that I got. So we are starting here to look right at the point where the server is about to start listening, and we see the first thing that gets created, kind of hard to see, is a TCP wrap, right? And if you have trouble seeing this, that's kind of going to prove my point. So now we're going to run this. It's only going to be about half a second, and I slowed it down. So the first thing you're going to see is the server listening. Then you're going to have 3 client requests coming in. So server listened, client request, another client request, and the last client request, which you can't see because I messed with my browser thing, but it's over here, right? As you can see, we can get some cool information. I tried to color this all to make it a little easier to read. You can see here these 3 things. That's when our server started listening and actually created and logged to the console, hey, I'm listening on this port. And that's when we get all these things created. And you can actually see here in our stack trace that that's what actually happened. Server and listening down there. And that's when these things got created. Now, OK, zoom function wants to confuse me. So now we have a bunch of tick objects here. This is all just for one client request. We can see the HTTP parser, which I colored red. The point is, it's a bunch of information. And when I said it's hard for you to read, well, I tried my best, right? But this is a lot of stuff, right? A lot of things are happening on the hood, a lot of information. And we only looked at half a second. So if you're just like using async hooks, basically I would call it the raw API, the low-level API directly, and you're trying to make sense of it, you're going to have a problem because it's just too much stuff. But that's, in a way, the whole idea. Like async hooks was supposed to provide you a really low-level API that could give you anything that you would ever want, and it does. So it's a little much, right? Therefore, I believe that not very many of us will actually use this API directly, because you actually have to have an understanding of how Node.js works on the hood. You have to understand, OK, there are like 5 tick objects. That means I made a server connection. I mean, who would know that, right? So the idea is that probably, I think, most times this will be used as a way to create a higher level API on top of it, which then is easier understood, right? So the data that we basically collect then needs to be presented in a way that makes it easy to relate to what you are actually doing in your app. Like, I read a file. Show me that. Don't show me all these tick objects, for instance. And then also, if I'm only concerned about my file system performance, if my network performance is fine, I don't need to collect data about that, right? I only want data about file systems. So we need to be able to kind of like isolate certain areas for which we collect data. Because if you just look at it directly, this is kind of like your event loop, right? And all your activities running around, that's kind of how it would look like. Like you would have no idea of what's going on because it's just too much. So the first thing we can do is we can identify low-level operations. And what do I mean by that? So if you have an fs read file, for instance, it actually does 4 operations for you under the hood. It opens a file, then first it stats the file, then it opens the file, then it reads the file, and then it closes the file, right? But you probably, I mean, most of us probably don't use these methods directly too much. We're just going to say fs read file, right? So, but even those low-level operations then have the same provider type. So even for fsstat and fsopen, for instance, it will tell you the same type. So you still don't know which one you're actually dealing with. But obviously, even though they are kind of file system operations, they are not exactly the same thing. So, but we can identify which one we're actually dealing with if you're looking closer, if you're looking at the stack trace a little bit and knowing a little bit about Node.js core, or if we look at the resource that's attached. So what then we can do, we can identify what you're actually dealing with and then expose it to the user in a much easier, understandable way, or maybe pass it down to a downstream processor that way. And the downstream processors then could then group it, right? We can say, okay, I saw these 4 operations, and I know they're related to a read file, and I can actually see that they are related via certain indicators. So I'm going to actually show you that it was an fs read file, because that's how you think about your code and your application. And then I can say, I only want to track certain parts of the subsystem of Node, right? And I also think that we will have 2 modes of tracking. So basically, if you're tracking your process, right, you're looking at CPU usage and memory usage, you will not take a heap snapshot every second. That would kill your server, right? So I also believe the same is true for async hooks. We'll basically track at a less detail while the server is running pretty much the whole time. And we'll just basically count how many fs reg wraps do we see, how many file system operations are going on. And then basically, once we have outliers, that's when we'll say, okay, now we need to basically get more information. And I will take the performance hit into, I will live with that because I need that information. It's kind of similarly like you see a CPU usage spike, and you say, now I'm going to profile my app, right? But you don't do that all the time because you know it's going to hurt your performance, but you want that information, so in that case, you take it into account, but you live with it, basically. So since at NodeSource, we're trying to help people to use this, right? Our clients and everyone else, trying to make it easier for them to understand what's going on in the application. I already started working on such a high-level API. So here, for instance, we have the file system collector. So there are basically 2 things, collectors and processors. File system collector, basically you create one like this. You pass options, which basically define how detailed do I want to track. Right? In this case, for instance, it will capture stack traces by default, but I can turn that off. It does not capture the resource attached to the async activity, but you can turn that on. Then you enable it. Then you do a bunch of stuff with files. And when you're done, you basically can disable it. And then I clean up all resources. And that part is really important because basically when you're capturing async resources, by the time you get the destroy, you need to let go of everything you held on to the resource, right? Because if you don't, the garbage collector cannot collect that asynchronous resource. And then you basically will have yourself a memory leak. But here, what could have happened is when you basically were done, there might be some resources floating around that haven't been destroyed yet. I still need to let go of them. So that's basically what that does. And then since we collect the stack traces, we also maybe at this point want to process the stacks. Again, we don't do that, right, while we're collecting because that has an overhead, right? Here's the same one for a network. And it basically has the same API, right? Obviously, that's intentional because we want to make this easy to use. But then again, like if you want interested in file system, you use this one here, network, you use this one. And then you will collect all that and you will pass it to a processor, right? If you want to, so at this point we collected, I would still say kind of raw data, but you want to make it even nicer, right? So then you pass that to the processor here, you give a few options of what to include and so on. And then I'm going to show you how cool that can be. So I have 3 demos here. The first one, we'll just look at a file system collector. And basically, we have a reader here. And all that does really is read a bunch of files. But before we do that, we turn on the file system collector. We also get the processor, but we don't do anything yet. And then basically when we are done collecting all the information, and reading all the files, we process stuff a little bit here. Then we write out the kind of unprocessed, right? Like still like kind of raw data to this file, and then we process it further, and we write operations. I call them operations because at that point we group them into operations. We write that to another file. So let's run that. If you look at the first file that gets created, we can see that it's kind of useful data, but as you can see, it's all just like these objects, and all I know about them is that they are fsrec wraps. Whoever came up with these names, Trevor. Anyways, so you don't have too much data, right? Like, I mean, you do have too much data, but it's hard to make sense of it, right? So if you then look at the process version, you can actually now see that, okay, it was identified as an fsread file operation. You have the life cycle here, right? So when it was created, destroyed, and so on. And you have the different like sub-operations, right? The low-level operations here. So we have open, we have stat, and we have read, and so on, right? And now we can visualize that too. So if you look at here, we have this awesome dashboard. Obviously, it's not awesome yet. It's just for this talk to just give you an idea where this could go. It's not too pretty. I'm not a web developer. But we can get a bunch of information. So we have, for instance, each rectangle is a file system operation, right? And the longer it is, the longer it took. And so we can see, okay, this one is here. We can even get where basically we read the file. We can get that information. We can see the registered callbacks, like on read file and so on. And we can, down here, it's a little small, but you can get a wealth of information that I basically pulled off the resource, including we can even see what was in the file that we read, if you wanted to, right? Wouldn't recommend it to do that all the time. You have to think about security, but you could. Now, the other demo I'm going to show you is for the network. So in this case, we have basically a server that is running, and it just sits there and running, and the client will just request from it. And that's pretty much all there is. One thing I want to show you, though, is that, as you all know, like we at NodeSource, we built a drop-in Node.js replacement in Solid that has a bunch of other cool features, but it is fully compatible with Node. So everything that works with Node also works in Solid. So I'm just going to show you here. In this case, I will actually run my server with Solid and the client as well, and things will still work the same way. So here, I'm running my server, and all these files get saved. If I refresh, we have here the server listening, right? And obviously, it listens the whole time. It never stops listening, so that's why that's a white rectangle. And here we have the client requests coming in, right? And again, we can get a bunch of information. It's kind of hard to see, but it was identified as a TLS server connection. Here are the different operations, a socket, shutdown, whatever. Now we can also run it from the client's perspective to see what the client would collect. So we do that, and we refresh. And then we have, from the client's point of view, we have the request here. Again, this was HTTP client connection. You can click on that, get a bunch of information. And here we can even get the headers. You can see what route the client was requesting. Really, really powerful stuff if you want to get insight into your process, right? Final demo, I want to show that you can actually then combine these together, right? So again, just for fun, we run it with nsolid. So this is a server running, and this server basically what it does, at every request, it will just read a file and then respond, just for demo purposes. But basically we can see here now that we have the request coming in and being served, and it reads the file in the meantime. So we can also see the parent-child relationship here, right? Like, so the execution context of the file read would be obviously the server handling the response, right? So again, we can see a bunch of information. Where was it registered? Where am I reading the file? We can look at the request also. We can see what callbacks were registered and so on. And if we run it I'm running out of time, but I'm just going to show this real quick. If we were to run this with, actually, never mind. Let's move on. But you can get more information, that's all I want to say. You can capture more about the activity to where, again, it will show you which file like what was in the file that you're reading, pretty much anything that's hanging off that resource that you're getting passed. So that brings us to the end of the talk, actually. And here I have some resources, though, if you're interested. So the first part here is about async hooks in general. There's a really cool blog post out there that basically also talks about the lifetime methods. It's illustrated. It's kind of fun to read. Check it out. And then here is the documentation. Actually, the documentation is very, very detailed about async hooks. So you can pretty much learn anything and more that I just told you from there. And then here I have a bunch of links related to the high-level API that I'm working on. If you follow this link here, you're going to get something like this, where basically you can see a lot of work already went into this. And there are two parts to this again, the collectors and the processors. And here are the related links. I so far did the network and FS parts. So again, if you're interested, would love to, if you play with this, maybe find some bugs or maybe help me fix them. It's very well tested and very well documented. So check that out. And obviously also, I would like you to check out our installer platform, which I helped build at NodeSource. It's pretty awesome. We're very proud of the features that we added there to help you, again, get insight into your processes and monitor and so on. Also, since I don't have time for questions, I will be at the NodeSource booth after the talk. So if you have any questions about either async hooks or install it, come see me. I'll be around for at least half an hour there. And that's the end of my talk. Thank you.